Hello everyone, welcome back to my channel InfoSecla. Today we're going to talk about JWT, which stands for JSON Web Token. In this video, I'll show you how vulnerable JWTs can expose sensitive information, compromise your applications, and even allow attackers to bypass authentication entirely. From signature validation mistakes to exploiting weak secrets, we'll uncover some vulnerabilities that hackers use, and especially how you can fix this. Now, ready to verify your web application? Let's get started. So the learning objective of this room is to learn about token-based authentication, JSON Web Tokens, or JWT, why JWTs are popular to use, and the security considerations when using JWTs. We also try some hands-on exercises to see how these vulnerabilities are exploited. All right, so what is token-based authentication? First, we're going to talk about the rise of APIs. Application Programming Interfaces, or APIs for short, has become incredibly popular today. One of the key reasons in this room is the ability to create a single API that can serve several different interfaces, such as the web applications and mobile application at the same time. This allows the same server-side logic to be centralized and reused for all interfaces. From a security perspective, this is usually beneficial as it means we can implement server-side security in a single API that would then protect our server regardless of the interface that is being used. However, the new session management methods are also created with the rise of APIs. As cookies are usually associated with web applications through the web browser, cookie-based authentication for API usually doesn't work. This is where the token-based session management comes into place. So basically, in a regular web application, cookie-based sessions are being used, and because of some built-in security features of browsers, the cookies are protected and secure. For other applications like mobile applications or any other web interfaces, they don't have the browser built-in features to protect the tokens. Because of that, the token generated by the server is hardly protected by the browsers, and the responsibility to secure such tokens falls on to users or the developers. Token-based session management. Token-based session management is a relatively new concept. Instead of using browser automatic cookie management features, it relies on the client-side code for the process. After authentication, the web application provides a token within the request body. Using the client-side JavaScript code, this token then stored in the browser local storage. When a new request is made, JavaScript code must load the token from the storage and attach to the header. While the most common type of token is JSON Web Tokens, or JWT, which are passed through the authorization bearer header. However, as we're not using browser built-in cookie management features, it is a bit of Wild West where anything goes. Although there are standards, nothing is forcing anything from sticking to these standards. Tokens like JWTs are a way to standardize token-based session management. Okay, we're going to talk a little bit about the API. API is, during this room, you will perform exploitation against several APIs. APIs can be documented using several different methods. One popular method is creating the Postman projects or Swagger file. Why we encourage you to experiment with these solutions, they require you to have an account, which we avoid forcing in this room. A simplified explanation of the API is provided. The API remains consistent for all examples except for the last one, which has conditional features. As you walk through the exercises, refer to the section guidance. So we're going to have a post request to authenticate and receive your JWT, and the GET request to get details about your user, and ultimately perform the privilege escalation to recover the flags. And this is going to be the URL that we run. So I guess there are going to be multiple examples with numbers. Example 2. So we're going to be having multiple examples. And the username is going to be to the users and the password with the example number. Okay, so these are the API credentials. Below are the two curl commands you can use to interface with the API for authentication. We run this command, curl, with the header content type application JSON, and a post method. And this is the data of the post request and the URL. All right. For user verification, we run a get command with the authorization header right here. Okay. So the JWT token component has to be replaced with a JWT received from the first request. Okay, So basically we run this one, we get a JWT, and we'll be using that JWT's value to insert here and to perform any other GET request. Understood. So what is the common header used to transfer the JWT? Oh, pronunciation. There. Okay, JSON Web Tokens. So let's talk about the structures of the JWT. There are three sections: the header, the payload, and the signature. As it shows in this image, the header is right here, the payload, and the signature. The header usually indicates the type of token, the type right here, which is JWT, as well as the signing algorithm that is used. In this case, is HS256. The payload is the body of the token, which contains the GLAMs. A GLAM is a piece of information provided for a specific entity. In JWTs, there are registered GLAMs, which are GLAMs predefined by the JWT standard, and public or private GLAMs. The public and private defined by the developers. It is worth knowing the difference between the public and private GLAMs, but not for security purposes. And it's not going to be our focus, okay? So basically, GLAMs are just any blocks of information that we can get from that JWT. So in this case, it's going to be the name of super hacker, and then this is maybe the issue date, I believe. Issue at, yeah. Signature is a part of Web token that provides a method for verifying the token's authenticity. The signature is created by using the algorithm specified in the header of the JWT. So this is going to be the algorithm used to provide the signature of this token. Okay, that makes sense. Signing algorithms. Although there are several different algorithms defined in the JWT standard, there are a few that we should focus on. None. The non-algorithm means that no algorithm is used for the signature. Effectively, this is a JWT without a signature, meaning that the verifications of the claims provided by the JWT cannot be verified through the signature. Symmetric signing. A symmetric signing algorithm such as HS265 creates the signature by appending a secret value to the header and the body of the JWT before generating a hash value. Verifications of the signature can be performed by any system that has the knowledge of the secret key. Okay. Asymmetric signing. An asymmetric signing algorithm such as the RS256 creates the signature by using a private key to sign the header and body of the JWT. This is created by generating the hash and then encrypting the hash using the private key. Verifications of the signature can be performed by any system that has knowledge of the public key associated with the private key that is used to create a signature. So JWTs can be encrypted or called JWEs, but the key power of JWTs come from the signature. Once a JWT is signed, it can be sent to the client who can use this JWT wherever needed. We can have a centralized authentication server that creates the JWT used on several applications. Each application can then verify the signature of the JWT. If verified, the claims provided within the JWT can be trusted or acted upon. So HS256 is an example of symmetric. It's funny. Okay. RS is asymmetric. And what's the name used for the encryption, or JWE? All right, sensitive information disclosure. The first common issue we'll dive into is the exposure of sensitive information within the JWT. A common cookie-based section management approach is using the server-side section to store several parameters. In PHP, for example, you can use the section var data to store a value associated with a user section. These values are not exposed to client side and can therefore only be recovered by the server side. However, with the JWT or with the tokens, the claims are exposed to the end user. Meaning that if the attackers can reverse engineer the token, they can easily obtain the sensitive information embedded within the token. This sensitive information can be credentials, disclosure with a password hash, or even worse, the clear text of the password being sent as a claim. It can also be an exposure of the internal network information such as the IP address or the hostname of the authentication server, which is web, right? Let's try them. Let's take a look at the practical example number 1. Okay, we go to make it easier, I'm going to copy paste this one because I believe we're going to reuse this one several times. And let's see, this is the IP address. Change to a file. So that's correct. This will provide with a JWT token. Sorry about that. Let me rerun everything. So we have this command. Run it and we receive the token right here. So this will provide you with a JWT token. Once recovered, decode the body of the JWT to uncover sensitive information. We can decode the body manually or use a website such as JWT.io. Okay, we're going to use this one. So we have the type is JWT, the algorithm uses HS256, and we have the user and the password right here. Admin, and we also get the flag. So this whole section here is considered a claim of the JWT. Okay, the development mistake. In the example, sensitive information was added to the claim as shown below. Right here, okay, the fixed values such as the password or flag should not be added to the claim as a JWT token will be sent client side. Instead, this value should be securely stored on the server side in the backend. When required, the username can be read from the verified JWT and used to look up these values as shown below right here. So this is a code of the payload, and then this is username going to be getting from the payload, and the flag should be get from the database lookup command function right here. Okay. What is the flag for example 1? Look at it here. So that's sensitive information disclosure. Moving on, signature validation mistakes. The second common mistake with the JWT is not correctly verifying the signature. If the signature isn't correctly verified, a threat actor may be able to forward a valid JWT token to gain access to another user account. Let's examine the common signature verification issues. First is not verifying the signature. This first issue is where there's no signature validation. If the server does not verify the signature on the JWT, then it is possible to modify the claims of the JWT wherever you want to be. While it is uncommon to find APIs where no signature validation is performed, signature validation may have been omitted from the signal's endpoint within the API. So depending on the sensitivity of the endpoint, it can have a significant business impact. So let's try this second command right here. It's going to be the same, except for the passwords is different, and then the endpoint is different. Okay, we get another token. Let's see what it is. Okay. So we get a token. Once authenticated, let's verify the user. This is a command to verify the user. It's using the post request. Is it? Oh no, it's using the get request. This. And we're going to put the token values right here. Welcome user, you're not admin. You're not admin. Okay. As we can see right here, yes, admin 0, meaning that this user is not admin. However, let's try to verify your user without the signature. Remove the third part of JWT, leaving only the dot. So we can try this command without the very last part of the JWT. And I think it should work. All right, cool. So we get the same thing. Message, welcome user, you are not admin. Now, because we don't have to verify the signature, we can actually change the content. Or especially in this case, we want to see the values of the admin, right? It's a admin and change the value to 1. Copy and paste. That's want to make sure. And because we don't need to verify the signature, so the last part can be omitted. We should get, now this is going to be admin. Okay. Welcome admin, you're admin. Here's your flag. All right. The JWT should always be verified. All additional authentication factors, such as certificates, should be used for server-to-server communication. The JWT can be verified providing the secret upload the key. And this is the code to provide the secret keys, okay? And specify the algorithm, which is the HS256. Okay, do we have to answer? I think we have to answer the flag right here. You know what? Let's just, instead of going back and forth, I'm going to put that in a note and we can just like answer all the questions in once. The fix, okay, we talk about this, downgrading to none. Another common issue is a signature algorithm downgrade. JWT support the non-signing algorithm, which effectively means that no signature is used with the JWT. While this may sound silly, the idea behind the standard that is for server-to-server communication, where the signature of the JWT was verified in an upstream process. Therefore, the second server would not be required to verify the signature. However, suppose the developers do not lock in the signature algorithm, or at the very least, deny the non-algorithm. In this case, you can simply change the algorithm specified in your JWT as none, which would then cause the library used for signature verification to always return true, allowing you, again, to forge any claims with your token. Let's see how it does. Authenticate to the API receipt with the user, so we're going to reuse this one. This is example 3, so and this is the token for the users. see what it is. Okay, so we can change the algorithm to none. Let's see. Let's try it. Oh, no. Before we do that, we have to try to verify the user using this one. This command right here. This is assemble 3. Welcome user, you're not an admin. Okay. So now let's try this one. We've changed the type of algorithm to none. And let's see if we can get the same result, the same output. Genetically could not be read, signature verified. Verification failed. Okay. Authenticate your API to receive your JWT and verify your user. Okay, we did that. Perform this attack, you need to manually alter the algorithm claim in the header to be none. Oh, we need this one. We need to with them. Okay. So this is the original token. Put it here. Form base 64. What? True base. Change this one to none. And this should be replaced right here. That's correct. I'm not sure. It says that JWT could not be verified. I did it wrong. This one should be JWT. Sorry, my bad. The algorithm is none. My bad. Yes, my bad. See. Now this should work. Welcome user, you're not admin anymore. Okay. So I changed the algorithm to none and we still get the same output. Now let's go and modify the claim. Admin, and it should be 1. Code 1, username is admin. I got the old one. My gosh. This is embarrassing. Okay, welcome to flag number 3. TryHackMe and a long string. Okay. With symmetric secrets. If a symmetric signing algorithm is used, the security of the JWT relies on the strength and entropy of the secret used. If the weak secret is used, it may be possible to perform offline cracking to recover the secret. Once the secret value is known, you can again alter the claims in your JWT and recalculate a valid signature using the secret. So this is going to be example number 4. For example, a weak secret was used to generate a JWT. Once you receive a JWT, you have several options to crack that secret. For our example, we'll talk about using Hashcat. You could also use a solution such as John, who can use the following step to crack it. Okay. So first, let's retrieve the JWT. We are at example number 4. To modify this, please got a token in go to JWT.text. We're going to download this one, a common JWT secret list. We have JWT secret list, we have JWT.text, and we want to use hashcash. Hashtag.m 16500.a0 JWT text, and then JWT secret list. Let's run it. Once you know what the secret is, you can forge a new admin token to recover the flag. I don't know. We'll see. See? Well, no. Wait, so what is it token? So it's using HS 256. It looks like okay, so the secret is secret. Now, how do we generate a new token? Right. Here we're gonna have to use a Python script to do it. Import JWT. Wait, hold on, let's see. Here I import JWT, okay. Let me make sure. How do we do that? Username equal, no, this is not signature algorithm. So let's see. Encode JWT encode with some hello. So we gotta, the secret, the algorithm. Okay. So we have the secret right here. We have the algorithm is step 1. So we have to fit category 1. All right. Encode JWT encode. JWT equals JWT equal. And we're going to put this one. First one is secret. Second one is algorithm equals and case 256, right? Yeah. And then the first one, JWT. What is it in the first one? Some hello. The payload is going to be this one username. We are going to use admin and with password. Okay, this one's going to be the payload. So we got the payload, we got a secret, and now we got the algorithm. Let's make sure there's no typo. Okay, algorithm with an F. There we go. Let's make sure that the packet is installed. JWT, okay. It's been installed. Let's run it. So algorithm with no S. Okay. So cool. So we got a token right here. Let's try to verify the admin user. Example 4. There we go. Welcome admin. This is flag number 4. Okay, moving on. So development mistakes. The issue occurs when a weak JWT secret is used. This can often occur when the developers are in a hurry or copy code from examples. The fix: a secure secret value should be selected, as this value will be used in software and not by humans. A long random string should be used for secrets. Signature algorithm confusion. Another vulnerability. The last common issue with the signature validation is when an algorithm confusion attack can be performed. This is similar to the non-downgrade attack. However, it specifically happens with confusion between symmetric and asymmetric signing algorithms. If an asymmetric signing algorithm, for example RS-256, is used, it may be possible to downgrade the algorithm to HS-256. In these cases, some libraries would default back to using the public key as a secret for the symmetric signing algorithm. Since the public key can be known, you can forge a valid signature by using the HS-256 algorithm in combinations of the public key. So let's go through number 5. So basically, what this means is in some JWT, it's going to display some public key from the server, and we can actually use that public key as the secret key to generate a new token using the symmetric signing algorithm like HS-256. We can try this one, example 5. Here we've got a public key. We also have the token. Okay, so we will have to modify the generate token JWT Python script. The generate, and over here, user, and then 0. Let's try it first. Just want to make sure that it works. Hello, like this. We have put the key. Oh no. Oh, note, we recommend that you use a tab box for this practical example. Since the PyJWT is already installed for you before running the script, edit the file right here. Okay, using your okay, go to line 143, then proceed to comment out the lines, run the script. You will also need to tamper with the PyJWT library's algorithm PY file on line 258 to remove its SSH key. So it looks like the package has fixed this vulnerability, so we are not able to run the script. We have to go to the file right here and edit it. Python free this package. JWT. What? Not this one. Help. No, we know it was a directory. Hold on. JWT and then algorithms py. And now we're moving down to line 143. Uh, 143. This is this one? Yeah. Coming out this one. Sorry guys, I'm learning Vim, so I'm a little bit slow right here. 44, 5, 46. Yeah, let's run the command again. Oh, we have to remove this one too. So 258. J. What is it? I don't see it. To remove is SSH key condition. Hmm. I don't see it. Invalid key and private key. Is it the correct file? You will need to tamper with the PJW library algorithms. So that is the scroll down to home. Yeah, this is commented. It came from our RSS. Oh yeah, we've commented out this one. Raise value specific areas. It still get me the error. What in the world? 4, 3, 4, 5, 6. Yeah. And home regenerate. Oh yeah, it worked. So this is going to be a new token. And try this one to verify the user. Username is user. Oh, let's try this. We're at example number 5. Welcome user, you're not admin. Okay, so now we can actually change this one to admin, and admin is 1. So we have to generate again. Welcome admin, you're admin. So this is flag number 5. Okay, the development mistake. The mistake is in the example is similar to one example number 3, but a little bit more complex. Why the non-algorithm is disallowed? The key issues stem from both symmetric and asymmetric signature algorithms are being used. Like in this one, the payload JWT. Okay. So in these algorithms, we have an array of allow algorithms, HS256, HS 384, 510, 512, and RS 256, 384, 512. So these are all possible algorithms that can be used to generate a JWT, which causes confusions in the JWT generation process. The fix, where both types of signature algorithms can be allowed, a bit more logic is required to ensure that there's no confusion. Alright, so we can implement some checks, some logics for that one. Also, we have to use the most recent updated packages from Python. As you saw earlier, I wasn't able to perform the script because there was a patch within the POI JWT library. But if you're using the old version of that one, then it may be vulnerable. And if you don't update, then you may be yes, cool. Okay, time to answer the question. What is flag number 3? Right here, my bad, my friend. And the 4. And number 5. Moving on to the next one, JWT Lifetimes. Token lifetime, before verifying the signature of the token, the lifetime of the token should be calculated to ensure that the token has not expired. This is usually performed by reading the expiration claim from the token and calculating if the token is still valid. A common issue is that if the expiration value is set too large or not set at all, the token will be valid for too long or might be even never expired. With cookies, the cookie can be expired server-side. However, JWT do not have the same feature. If we want to expire a token before the expiration time, we must keep a block list of these items or these tokens, freaking the model of these centralized applications using the same authentication server. Therefore, the key should be given to choose the correct expiration date value, given the application's functionality. For example, a different expiration value is probably used between a mail server and a banking application. Another approach is to use refresher tokens. If you are going to test an API that uses JWTs, it is recommended that you do some research into this. Okay, moving on to example number 6. The JWT implementation did not specify any value, meaning tokens are permanently used or permanently persistent. Use the token below to recover your flag. And then for the user or for the admin, okay, so here's a flag. The fix, an expiration value should be added to the claims. Once added, most libraries will include reviewing the expiration time for the JWT into the checks for validity. This can be done as shown in the example below. So this is the lifetime right here, and then this is a payload, pulling the lifetime value, the expiration value right here for the lifetime, cross-service relay attacks. The last common misconfiguration we'll review is the cross-service misconfigurations. As mentioned before, JWTs are often used in systems with a centralized authentication system that serves multiple applications. However, in some cases, we may want to restrict which applications are accessed with a JWT, especially when there are claims that should only be valid for certain applications. This can be done by using the audience claim. However, if the audience claim isn't correctly enforced, a cross-service relay attack can be executed from a privilege escalation attempt. The audience claim. JWT can have an audience claim. In cases where a single authentication system serves multiple applications, the audience claim can indicate which application the JWT is intended for. However, the enforcement of this audience claim has to occur on the application itself, not the authentication server. If this claim is not verified, as the JWT itself is still regarded as valid through this verification. It can have unintended consequences. An example of this is if a user has admin privileges or a higher role on a certain application. The JWT allocated the user has a claim that indicates this, such as admin equals true. However, that same user is perhaps not an admin on a different application served by the same authentication system. If the audience claim is not verified on this second application, which also makes use of its admin claim, the server might mistakenly believe that the user has admin web privileges. This is called the cross-service relay attack, as shown in the animation below. So first, you log in on the web browser and send your credentials to the authentication server. For application A, here admin is false. The user is not the admin on application A. Then the same set of credential is sent to the authentication server, but this user is an admin on application B. And the confusion happens when the authentication server mistakenly grants the admin permission for application A, which is not supposed to be. So let's take a look at the example to see how it works. For this practical example, there are two API endpoints, example 7a app A and example 7 app B, scattered. So as usual, we're going to authenticate to the server using this command, curl contain post username, but we are going to add another piece of information in the data, which is the application app A and app B. In this case, let's try app A first. And we got a token for the user on app A right here. We are going to use this same one for app B, but later. Authenticate to example 7 using the following data segment. Okay, so this is what we just did. Password 7 application for app A. You notice that an audience claim is added. So let's take a look at it. Okay, right here. We have username is user, which is not an admin on this specific application A. All right. Use this token in both the admin and user requests to make sure you make your example app A key. So we get this token. Let's verify the user. Where's the command to verify? Right here. This is a command to verify the user. We are going to use this token from application A. The IP address is this one. Example 7. App A username equals user. Welcome user, you are not an admin. Okay, cool. So let's try this one. Use this token for use. So let's try the same thing with the admin user. Let's see what it gets. Unauthorized, you are not an admin. Okay. So it looks like it works for both users. How about we try app me? Does it work? It should work. Yeah. Because the token is only valuable for application A, not application B, so it shouldn't work. Okay, so this is expected. Okay, you will notice that while app A accepted token, you are not admin. Okay, and app B does not accept the token as the order is incorrect. Yes, we just verify that. Authenticate to example using the following for the app B. Okay. So here, and we get a new token. Let's see what it is. Okay, on app B, this is the user. The user is admin on application B. Okay. You'll notice that the audience claim is admin and you are an admin this time. Use this token again to verify yourself on both applications and see what happens. So because now I'm on app B, I can just use this token from app B to verify the user. This one's supposed to be app B. Okay, valid request made. How about we try with the admin? Okay, welcome. You are an admin, but there's no flag for you. So how about I try token retrieve from app B, but getting the request from app A? Then here, let's change it to see what happens. Invalid request for the user. How about the admin? Cool. All right, so on application B, the user is an admin, but on application A, it's not supposed to be an admin, but using the token retrieved on application B, we can actually verify the user on application A, which the authentication server accidentally granted admin permission to. I'm sorry, again. So basically on application B, the user is an admin, and the authentication server was confused that it gives the same admin privilege for that user on the application A, which isn't supposed to be. So this is the cross-service relay attacks. The development is misset. The key issue is that the audience claim is not being verified on application A. This can be either because the audience claim verification has been turned off or the audience scope has been set to Y. The fix is the audience claim should be verified when the token is decoded. This can be done as shown in the example. So this is the code to verify the audience. What is the flag number 7? In this room, several common misconfigurations and vulnerabilities with JWT implementations were showcased. As a summary, take note of the following. As JWT are sent client-side and encoded, sensitive information should not be stored in the claims. The JWT is only as secure as its signature. Care should be taken when verifying the signature to ensure that there is no confusion or weak secrets being used. JWT should expire and have sensible lifetimes to avoid persistent JWT being used for by a threat actor. In SSO environment or single sign-on environments, the audience claim is crucial to ensure that specific applications JWT is only used on that application, as JWTs make use of cryptography to generate their signature. Cryptographic attacks can also be relevant for JWT exploitation. We'll dive into this a bit more in our cryptography module. In this room, we did not cover a JWKS spoofing attack. If you're interested in performing this exploit, take a look at this room. What's that? Okay, that's a hammer room. Okay, I understand. All right, so that's it for today's room. I hope you learned a lot about the JWT and its securities. I hope you also learned some of the common vulnerabilities in JWT and how to mitigate and prevent them. If you have any questions, feel free to reach out to me. I know it's a bit confusing for a lot of you. I was confused at first too, but eventually the more you do it and the more you practice, the more comfortable you get with the concepts. All right, thank you very much for watching, and I'll see you next time. See ya.